Hello friends, let's rapid revise the quicksort algorithm. First of all, the quicksort algorithm is in-place algorithm. In-place means that it doesn't require any extra space to store the output like that in the case of merge sort. It requires an extra amount of array. Okay, that's why the space complexity is less than n. Okay, the space complexity is less than n and it is known as in-place algorithm. Second of all, it is unstable algorithm. Unstable algorithm means if suppose we are given a list of elements like this where the elements are repeated, so let us label them as A, B, C, D. When after sorting we get suppose after first sort, first partition algorithm, we get what as the 10A gets to the last position, so we get the required list as 10B, 10C, 10D and 10A. So unnecessarily 10A went to the last place. So this is when the repeated elements, when the order changes, then it is known as an unstable algorithm. Okay. Third is that QUICKSORT is the most practically used algorithm, we can say, and it is used wherever where actual sorting is needed. Okay, actual sorting जहाँ भी use होगी वहाँ QUICKSORT use होगा. Now let us study the algorithm in detail. Okay, let us study the algorithm in detail. So here is the algorithm, QUICKSORT algorithm, and suppose we are given uh, a list of numbers as like that 55, 90, 80, 70 and 40. Suppose we are given this list to sort in ascending order. Okay, so quicksort algorithm basically works in two phases. Okay, that is the quicksort algorithm itself. Okay, and second is the partition algorithm, which is also known as the hero algorithm because it does everything. Okay, so let's study in detail. First of all, here the list is this. So first of all, when we go to the line 1, okay, line 1, quicksort APQ. A means A represents the array which is storing the input, and P is the first element of the list, and Q is the last element of the list. Okay. Now proceeding further, so P is the first element and Q is the last element. Now we are heading towards the algorithm. Now if we are checking that if P is equals to Q, so P is not equals to Q, and it will be true only if when the whole statement will be executed and P when equal to Q is the terminating situation, we can say terminating. So we get to go, this is false, this statement is false, so we go to the else part. Okay, now in the else part we can say that see that I equals partition APQ. So it is in turn calling the partition APQ algorithm. Okay, so here what will happen is we are calling looking in this array and partition APQ is being called and I will be allotted whatever it will return. Now when it is called, we are x is being assigned value of AP. Okay, so x value will be 55. Okay, now second, what would be the second most important thing is the pivot selection. That is, pivot selection is one of the most important thing, we can say. Okay, because we can take any element as the pivot element. For the sake of simplicity, we are taking the first element as the pivot element. So we are assigning the value I to P, P to I. Okay, now what will happen? The loop will execute. Okay, so the loop will execute as j equals p plus 1. So j will be initiated with the value of I plus 1. So here comes j, and then it goes inside, and j is also less than equal to q, so it less than q. So if it goes inside, and if aj is less than x, What is AJ? AJ value is 90. So 90 is less than 55? No. So it goes inside. So it doesn't go inside. Then again here it goes to for loop and increments the value of j. Okay, j value will be incremented, and again it will check the condition j is less than equal to q. Yes. Then it goes inside aj is less than x, that is 80 is less than 55. No. So it doesn't go inside. Then again increment the value of j like this. J value will be 70 now. So 70 will be compared with 55 again. Again it is no, so j value will be incremented. Now here comes the situation where we get as j equals q, and so we proceed further. If aj is less than x, so we will compare. 40 is less than 55. Yes, so it will go inside, and while value of I will be incremented, that is I value will be incremented and it will go into 90, and swap ai and aj. ai is what? 90, and aj is 40. So these value will be swapped. Now what we'll get the list as? We'll get the list as 55, 40, 80, 70 and 90. Okay, after swapping we'll get the following list. So then again we will check j will be incremented and j is greater than q, so it will not go inside the loop and it will go out of the loop, and then swapping will occur. Swap ai and ap. So ai and ap will be swapped, that is ai is 90 only and ap is 55. So ai and ap will be swapped. After swapping, the value will become, the array will become as 40, 55, 80, 70 and 90. Okay, so here what we'll see is our pivot element was 55, and 55 comes into the right place. Right place means that the value to the left of the list is less than 55 and value to the right is greater than 55. Okay, so here we get the correct position of the pivot element, and the value of the correct position of the pivot element will be returned as I here. Suppose if the number labeling is done like 0, 1, 2, 3, 4, so 1 will be returned and I value will be returned. So here what will be the next calling statement would be quicksort of a p. P is 0, 0 to I minus 1. I minus 1 is 0 itself, and then calling of a comma I plus 1. I plus 1 is 2 and q is 4. So we get the two sublists as a00 and a24. a00 will be terminated by the terminating condition of the if statement, and q will be again called quicksort, and it will go to else part, and we will get the correct sorted elements as follows by using the following algorithm. Okay, we will get what? 40, 55, 70, 80 and 90. Thank you.